Hello students, welcome to Sourav Sir Classes. Today we'll be solving the NBHM PhD Scholarship Exam questions from the January 2018 paper. We'll be solving questions which came from the section 2, that is the analysis portion of the paper. So let's start off with the question. The question is that, this is the question number 2 of section 2. So which of the following functions are uniformly continuous on R? Option A, fx is equal to mod of sine cube x. Option B, fx is equal to tan inverse of x. And option C, fx is equal to summation of fn x as n tends to 1, as n goes from 1 to infinity, where fn of x is equal to n into x minus n plus 1 by n if x belongs to the closed interval n minus 1 by n to n, and fn of x is equal to n into n plus 1 by n minus of x if x belongs to n close interval n comma n plus 1 by n, and fn of x is 0 in any other interval, in any other condition. So these are the functions which have been given. So we need to find out whether the functions are uniformly continuous or not. Now fx is equal to mod of sine cube x. This function is a real valued. In this function, derivative exists everywhere. Derivative exists everywhere. So therefore, this is basically uniformly continuous. Uniformly continuous. Okay. Now fx equal to tan inverse x. Let us draw the curve of fx equal to tan inverse of x. Now fx equal to tan inverse of x, if this is the y-axis and this is the x-axis, this dotted line represents y equal to pi by 2 and this dotted line represents minus of pi by 2, then tan inverse of x will look somewhat like this. As you can see that f of x equal to tan inverse x is continuous everywhere throughout from R to R. So therefore fx equal to tan inverse x. So therefore you can see that fx equal to tan inverse x is continuous everywhere. Is continuous everywhere on R. So it is uniformly continuous everywhere. So option B is also correct. Now in the third option you can see where it has been given that fx is equal to summation of fn of x, where n goes from 1 to infinity, and function of fn of x has been defined as given in the question, as defined over here. So as you can see here, the function is continuous. Fn of x is continuous, but the spikes above the x-axis, like the spikes that it occurs, so basically this is equal to f1x plus f2x, and this will go on up till f infinity of x. So basically, as you can see from here, the spikes above the x-axis becomes narrower. The spikes above the x-axis becomes narrower as s tends to infinity, or in simple terms we can say that the slope of lines of graph of fn of x, for f1x it will be somewhat narrow, for f2x it will be more narrower, and that narrowness goes on, and the slope of the lines of the graph of fn of x increases very fast, which shows that as s tends to infinity, as n tends to infinity, f of x is not continuous. This is the condition. So we can say that option C is wrong. So therefore the correct options are the graph of A is uniformly continuous, function A given by option A is uniformly continuous, and the function given by option B is also uniformly continuous. So these are the options. So today we have solved a question which came in the analysis part section 2 of NBHM 2018 paper. We'll be solving the next questions in the subsequent videos. Till then, keep watching Sourav Sir Classes videos for more solutions and content. Thank you very much.